Today, we're going to learn how to simplify radicals. This is a skill that sometimes will come up in 8th grade math. It might come up in Algebra 1, but then it is definitely needed in geometry and definitely utilized in Algebra 2. It's not required to be taught anywhere specifically, so oftentimes it gets overlooked. So this is going to be very helpful for you next year and especially the year following as you move through your math courses. Starting with, let's just make a list of all of our perfect squares, meaning 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 25, 36, 49, 64, 81, 100, 11 times 11, 121, 12 times 12 is 144. And most students can get through that just knowing their multiplication tables really well. 13 times 13 is 169. 14 times 14 is 196. Notice there the 6, 9, and 9, 6. They just flip there. So if you can memorize one, you can get the next one. And then 15 times 15 is 225. So if you can get through 12, there's just a few more, 13, 14, 15, to get you that 225. Honestly, most of them that we need is going to be like 1 through 36 to help us simplify. Let's start with just some basic examples. Number 1, the square root of 4 is equal to 2. Just to kind of recap here, this is a square root indicating we're looking for the two things that are multiplied together to make 4, and they have to be the same thing. So 2 times 2 is 4, therefore the square root of 4 is 2. Number 2, the square root of 81 is 9 for the same reasoning. 9 times 9 is 81. Number 3, the square root of 64 is 8, because 8 times 8 is 64. Number 4, 121 is equal to 11. Number 5, the square root of 36 is 6. Number 6, the square root of 1 is 1. And then number 7, what is going on here? We got fractions. And so, yes, you can take the square root of your numerator and square root of your denominator, and it would equal your result. So if I wrote it out, you could just break up the radical there. Square root of 1 is 1. Square root of 16 is 4. Final answer is 1/4 there. So nothing really crazy. Number 8, the square root of 9 100ths, same as the square root of 9 over square root of 100. So we would have 3 over 10 is our final answer there. And number 9, square root of 25 49ths. If I broke up those radicals, numerator and denominator, square root of 25 is 5. Square root of 49 is 7. 5/7. Final answer. So you can see how those are working out there. Now, in our next section, we are going to really get into the simplifying radicals. So the simplest form of a radical expression is when there are no more perfect square factors of that number, or in our next lesson, in our variable. So when the radicand, which is the fancy word for that number inside the radical, has no perfect square factors. In the process of simplifying, we are going to break down that radicand number inside the radical using the product property of square roots. If the square root of a times b, I can rewrite it as the square root of a times the square root of b. I can separate them, kind of like we were doing with the fractions above. So in our directions, we are going to simplify each expression, no decimals. We are not typing this into our calculator and getting a decimal answer because, as you know from 8th grade math, if I type in the square root of 24, that is not a perfect square and therefore is irrational. The decimal would go on forever without repeating. So I could never write the end of that decimal. I would eventually have to round it on paper pencil in order to write that number. I would have to round it. And in the process of rounding it, I'm actually cutting off some of those decimal places, and it's no longer equivalent to the square root of 24. So we are going to leave it in a radical form answer. No decimals, okay? So number 10, we have the square root of 24. Like I said, in the top on our list, we've got square root of 25, but not 24. So what we're going to do is use this product property of square roots and rewrite 24 into some factors that I can find the square root of. For example, 24 has factors 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. Okay, any of those, are they perfect squares? Actually, yes. The last one that I listed, the 4 times 6. 4 is a perfect square. So we are going to rewrite 24 as the square root of 4 times the square root of 6 because I can take the square root of 4. Square root of 4 is 2. So this is going to come out. No more square root of 4. Now it's a 2. And there's nothing more I can do with the square root of 6. So it's going to stay in the radical. Final answer, 2 radical 6. Or I could also read that as 2 square root of 6. Notice I didn't want to choose 2 times 12 to make 24 because 2 is not a perfect square, 12 is not a perfect square. It doesn't get me anywhere. So let's try again with number 11, the square root of 90. What can we use? What can we rewrite 90 as so that one of those factors is a perfect square? 9 times 10? 9 times 10 works. Is there anything bigger? We do want to keep that in mind as we keep moving. 9 times 10. So the square root of 9 is 3. Square root of 10, always think, is there any more perfect square factors of 10? I need to break 10 down more, and the best we can do is 2 times 5, and 2 and 5 are not perfect squares, so we are good. Square root of 10 there. 3 radical 10, or 3 square root of 10. Number 12, the square root of 63. So what about 3 times 21? No. 3 and 21 are not perfect squares, so try again. And you can use that list at the top, and that's why we wrote it there on our notes. So you can just work your way down. So think about 4. Does 4 go into 63? No. Does 9? Oh, well, of course. 9 times 7. The square root of 9 is 3, and there's nothing more I can do with the 7. So final answer, 3 radical 7. Number 13, the square root of 175. I hope it's jumping out at you. The factor of 25 will go into 175 because, like, I think about money and quarters, and that is a perfect square. So let's see. 25 times what is the 175? 7. So the square root of 25 is 5. There is definitely no other way I can break down the radical or square root of 7. So final answer there, 5 radical 7. Number 14, the square root of 48. So I definitely see that 4 jumping out at me. 4 times 12. Now this is not the best scenario, but I'm going to show you kind of how it all ties together. Let's work with this for a minute and let me show you a shortcut way for this one. So 4 times 12, the square root of 4 is 2, but look at 12. Again, in some of the earlier problems, I was like, you always need to double check the number left in the radical. Does it still have some perfect square factors? And 4 is the one that always likes to hide. He's really pesky. And of course, square root of 12 actually still has a perfect square factor. You would need to break it down again into 4 times 3. And again, the square root of that second 4 is another 2. So on the outside here, we have 2 times 2 with the radical of 3, or final answer would be 4 radical 3. You can do it that way. If you are very on top of, let me check my final radical, does it have any perfect square factors? Or utilize your calculator, keep going down that list of perfect squares. What's a bigger perfect square factor of 48? Try it out. It's actually 16 is a better answer. This would be your fast track, your shortcut method. Jump on over to 16. When you divide 48 divided by 16 is 3. That's a better match. This is going to be my shortcut. Square root of 16 is 4. 3 definitely has no more perfect square factors. Final answer. Let me box it because we've been boxing our answers here. 4 square root of 3 is my final answer. So either method, as long as you're always checking that your radicand inside does not no longer have any perfect square factors. And again, 4 is sneaky. He always likes to hide. Number 15, the square root of 72. We could do 4 times 18. We could do it. We could keep moving forward, but do you see what I see? The square root of 18 is going to have to be broken down again into 9 and 2. And we'll have something like 2 times 3 radical 2 or 6 radical 2. Is there a faster way? Yes. Another one that's kind of sneaky, and I always need to check if it's divisible by, drumroll, 36. 72 is divisible by 36, and it's times 2. 36 times 2 is 72. This is my fast track. The square root of 36 is 6, and we have a 2 left over. Again, it doesn't matter which way you go as long as your final answer doesn't have any more perfect square factors. Number 16, now we've got this like coefficient piece in front of our radical. That is fine. Let that number hang out. So we will leave 3, potentially multiplying with anything that comes out. And let's continue to simplify the square root of 27. 9 times 3, correct? 9 times 3. The square root of 9 is 3. I had the original 3 on the outside that we're going to multiply with. 3 times 3 makes 9. Radical 3 is my final answer. So on this problem, what I want to strike home is make sure you're writing this out. You're going to be required to show your work on this assignment. But in addition to that, if you're trying to hold all these numbers in your head, you're going to forget who's in the radical, who's out of the radical, who did I multiply with, who have I taken the square root of, because we took the square root of a 9, it came out as a 3, but there was still a 9 on the outside. So write it out. It's going to save you some trouble. 17, we have this negative 2 on the outside. We're going to break down this square root of 75. I'm seeing that 25 times 3. Square root of 25 is a 5. And radical 3, staying inside there. Negative 2 times that 5 is negative 10. Radical 3 is going to be my final answer on number 17. 18, we have a 5. Let's break down the square root of 24 times 5. The square root of 4 is a 2. So 5 times 2, radical 5. Let's simplify that 5 times 2 to make it a 10. Okay, so far, just simplifying numerical radicals. Notice there's no decimals here, okay? Leaving it in a radical form. So that's your first part of simplifying radicals. Again, we're trying to make sure that the radicand, which is the number inside, does not have any more perfect square factors, that it's no longer divisible by 4, 9, 16, 25, 36. And again, that's probably the limit. I rarely see a factor that's a 49 or a 64 or anything past that. No decimals, of course. And so practice through those, guys, and then we're going to move on in the next part looking when there are variables or they are algebraic radicals. I'll see you soon.